Welcome to this explainer. Today, we are taking a seriously mind-bending journey into the absolute architecture of reality itself. We're going to be exploring a fascinating academic monograph by Fred Y. Yee that proposes a highly rigorous mathematical way to look at the universe. It's called the five-dimensional Scalar-Vector-Spinor effective field theory, or, SVS-EFT for short. Now, if that sounds a bit intimidating, don't worry at all. We're going to break the whole thing down step by step.
Okay, let's dive into this. What if the universe's ultimate blueprint was actually written in 5 dimensions? And I'm not talking about some wild science fiction concept here, but a strictly disciplined mathematical framework designed to solve literally one of the biggest mysteries in modern physics. That is exactly the question this source material attempts to answer, giving us a totally fresh perspective on how reality might be organized at its most fundamental level.
To wrap our heads around this complex blueprint, we'll just follow a logical path, kind of like building a new house from the ground up. We'll start with the quest for unification, explore one state, many faces, explain this elusive 5th dimension, establish 3 principles of construction, and finally return to 4 dimensions.
All right, part 1, the quest for unification, the mismatch. So, the whole foundation of this problem is almost like a cosmic crime of mismatch. You see, modern physics relies on 2 extraordinarily successful but totally incompatible languages. On one side, we've got general relativity. This elegantly describes gravity through the continuous geometry and curvature of spacetime on a massive, macroscopic scale. But on the other side, we have the Standard Model. This deals with quantum fields, discrete particle matter, and internal gauge symmetries, basically what we call the fundamental forces of particle physics. They are both brilliantly, undeniably correct in their own domains, but they speak completely different mathematical languages. The source essentially asks, what if they only look disconnected because we're just missing a deeper, shared mathematical structure? Which brings us to part 2, one state, many faces, a unified solution. To build this unified solution, the framework uses something called a Clifford algebra, specifically a real algebra known as CL2,3. Think of Clifford algebra as essentially a mathematical Swiss Army knife for theoretical physicists. Normally, things like scalars, vectors, and spinors are treated as completely separate objects. They literally require different notations. But a Clifford algebra naturally contains all of them within a single multiplication law. It perfectly combines metric information, like distances, with oriented plane information, like rotations and spin, all in one unified space. It's pretty amazing.
Now, what's really interesting about this slide is how all these seemingly unrelated physical components just fold right out of the exact same mathematical object. The monograph calls this the one-state postulate. So instead of awkwardly throwing a bunch of unrelated fields together by hand, we just start with a single 5-dimensional multi-vector state. Then through a process of carefully controlled projections, this single state yields your scalar grades, your vector grades, your bivector grades, and even your spinorial ideals.
So, let's unpack that. What tools are actually hiding inside this SVS mathematical multitool? Well, when we break it down by grade, grade 0 gives us our scalar fields, like the famous Higgs boson or a radion. Moving up, grade 1 provides connection vectors for spacetime. Grade 2 is incredibly important. These bivectors carry gauge planes and spin planes, acting as the mathematical carriers of rotations and field strengths. And finally, algebraic ideals give us our spinorial components. Those are the fermions, the literal building blocks of matter. It is just an incredibly economical way to organize the universe.
Now for part 3, the 5th dimension explained. Time to de-sci-fi reality.
Let's firmly de-sci-fi this right now, okay? The author explicitly warns us against a really common trap. Quote, "The coordinate tau is not a second real time. It is compact, thermally normalized, and non-traversable as an observational direction." End quote. So to be crystal clear, we are absolutely not talking about time travel here. Having a second macroscopic time dimension would create massive problems. We're talking ghost-like modes, acausality, just total chaos for observable physics. Instead, this 5th dimension, which is called tau, functions as an order coordinate.
To really grasp this idea of Matsubara compactness, imagine the 5th dimension essentially looping back on itself in a tiny, tiny circle. And the period of this loop isn't just random. It's intrinsically tied to temperature and energy scales. This little circle basically acts as a carrier for boundary data, winding, and topological information. Meanwhile, the normal causal timeline that we actually experience moving forward remains strictly 4-dimensional.
The absolute brilliance of this approach is how it connects that looped fifth dimension directly back to mainstream orthodox physics, specifically quantum information cosmology. The author actually draws a direct lineage from things like Landauer's erasure cost, which proves that deleting information has a minimum thermodynamic energy cost, all the way to holographic bounds and black hole entropy. In this framework, the 5D SVS-EFT treats information and geometry not just as clever metaphors, but as mutually constraining physical forces anchored by this compact fifth coordinate.
Moving on to Part 4, 3 Principles of Construction, the EFT building codes.
Look, a physical theory can't just be an elegant math trick. It needs strict building codes to keep the theoretical house from falling down, right? The source inherits a triad of principles: action, duality, and equivalence, also known in physics circles as the Hamilton, Heisenberg, and Einstein principles. These act as the strict rules that enforce the organizational architecture of our 5D blueprint.
So the crucial point is really how these 3 principles filter the math into reality. First up, the action principle demands that any proposed sector absolutely must have variational dynamics. It has to fit into a cohesive mathematical action. Second, the duality principle strictly constrains quantum effects, making sure that wave-particle non-commutivity is handled consistently through algebraic projection. And third, the equivalence principle demands that when everything is said and done, the projected gravitational sector must recover universal metric coupling, meaning it literally must give us 4-dimensional general relativity back. If it fails that test, it completely fails as a physical theory.
Which leads us to Part 5, returning to 4 dimensions, bringing it back to reality.
And this brilliantly illustrates that the journey back to our reality requires a highly structured pathway called a projection hierarchy. We don't just instantly drop from 5D down to 4D. Instead, we take our 5D Clifford state, apply grade projections to get our vectors and bivectors, apply ideal selections to get those spinors, apply a compact projection to handle that looped fifth dimension, and finally do a real slice observation to guarantee our causal 4-dimensional reality. Every single step is rigorously defined.
You know, throughout this entire monograph, the author maintains a highly conservative scholarly posture. This is an effective field theory, or EFT. It is deliberately not presented as some finalized, mystical theory of everything. An EFT is a practical, testable working model. It's expected to organize operators at a given scale, preserve known symmetries, and ideally identify suppressed structures that could produce observable deviations. It is a robust, grounded framework that is meant to be tested against reality.
Which leaves us with a truly exciting question to ponder. How might we actually observe these 5D compact order residuals in our real 4-dimensional world? The author notes this framework should produce falsifiable residuals. We're talking tiny corrections that could actually show up in precision particle physics constraints, complex scattering tests, or even gravitational wave observations. The math is undeniably beautiful, but ultimately the universe will be the final judge. So what do you think? Could the ultimate blueprint of our universe truly be hidden in a 5th dimension? Thank you so much for joining me in unpacking this phenomenal explainer.